Have you ever stopped to think about how many ways you can arrange a simple deck of cards? It sounds innocent enough. Just 52 pieces of cardboard. But the math behind counting those arrangements reveals a scale of numbers so massive, it completely shatters human intuition. Welcome to the world of combinatorics. Let's start small. Imagine you have 3 blank books on a shelf. How many ways can you arrange them? For the first slot, you have 3 choices. For the second, only 2 are left. For the last slot, just 1. Multiply them together, 3 times 2 times 1. That's 6. In math, we call this a factorial, and it grows terrifyingly fast. Now, what if order actually matters, but you aren't using all your options? Say you're running a race with 8 people, and we want to know how many unique ways gold, silver, and bronze can be awarded. This is a permutation. The order matters because coming in first is very different from finishing third. But what if the order doesn't matter at all? Imagine you're choosing a group of 3 friends out of 8 to go to the movies with you. Picking Alex, Ben, and Chris is exactly the same as picking Chris, Ben, and Alex. This is a combination. Because the internal arrangement doesn't change the group, the options drop from 336, down to just 56. This brings us to the ultimate combination game, the lottery. To win, you have to choose 6 correct numbers out of 49. The order you pick them doesn't matter. The formula for this is 49 choose 6. Do the math, and you get nearly 14 million distinct combinations. Your single ticket is just one lonely drop in that massive ocean. To put 14 million into perspective, imagine lining up those 14 million lottery tickets side by side. That line would stretch over 2,000 miles long. Imagine walking along that highway, blindfolded, and trying to stop and pick up the exact winning ticket on your very first try. That's why winning is statistically an illusion. But back to that deck of cards. 52 factorial. That's a 5 followed by 67 zeros. Every single time you thoroughly shuffle a deck of cards, it is virtually certain that the exact sequence of cards in your hand has never existed before in human history, and never will again. Counting your options is the secret key that unlocks probability. Once you know how many total paths exist, you can calculate the exact odds of walking down any single one of them. Next time, we're diving into conditional probability, where new information completely flips the math on its head. See you there.